Hello, everybody. So today we're going to continue our discussion on logarithmic equations and solving them using our log properties by starting into Chapter 5, Section 4. And in 5.4, we will be solving logarithmic equations as well as more complicated exponential and logarithmic equations than what we've done in the last couple of sections. And then we will also use our properties to model and solve real-life problems. So the two basic strategies for solving exponential or logarithmic equations. The first one is to use the one-to-one property. And we actually used this property back in probably the first or second section when we covered this. But I'm going to go back over that just to make sure people understand how that works. The second one is using the inverse property. And what we'll do is get x and y equal to each other if we can get it rewritten so they both have the log with the same base. So you'll kind of see how they both work here as we work through here. But these are the two properties we're going to concentrate on today, which are the one-to-one property and the inverse property. And so looking at the one-to-one property, what you need to understand is that if the base of two exponents are the same, and we are stating that they're equal, then that means their powers also have to be equal. And that goes right along with the log equations as well. If you have log base A and another log base A, and we state that they're equal, then we know that the two things that are being logged are also equal. Now, the inverse property is where you have a base A, and then it's taken to a power of log base A. So anytime the A of an exponent matches, the base of an exponent matches the base of the log, they will end up canceling out. We've used this property a lot in some of our homework assignments, but you can see that the base of this exponent matches the base of the log. And when it happens, it all cancels, and we're just left with what's being logged. Same thing here. We have log base A of A to the x. All of that cancels, and we are just left with the exponent. So let's use both of these properties here to do a little bit of solving. So the first one you can see, we have 2 to the x power is equal to 32. Now, the trick to utilizing the one-to-one property is to rewrite this 32 so that it is also a power of 2. In this case, 32 is 2 to the 5th power. So now what you can see is I have 2 to the x equals 2 to the 5th. Clearly, the bases are the same. They're both base 2. There's a 2 here and a 2 here. So what that means then is the x and the 5 have to be the same. So our solution is x equals 5. Now the next one, the original equation is natural log of x minus natural log of 3, and that equals 0. Now what we have to do is we need to add natural log of 3 to both sides, and when I do that, I get a new equation. Natural log of x is equal to natural log of 3. Now natural log, of course, is log base e, so you can see we have log base e here and log base e there. They're the same, so that means x is equal to 3. And there's our final solution. That's also the one-to-one property. Now, the last one that we will use the one-to-one property for is this one right here. We have 1/3 to the x power is equal to 9. Now, what we have to do is we need to rewrite both the 1/3 and the 9 so they have the same base. So the 9, I would say, is probably pretty obvious. That is 3 to the 2nd power. That's not very hard. But this one's a little less obvious. We need to bring this 3 up to the top. Now, if you recall, that is 3 to the 1st. And if you recall, if you move something from the bottom of a fraction up, you can do that, but it makes the power negative. So what this becomes is 3 to the -1 power to the x power is equal to 3 to the 2nd. So we're almost there getting the bases to match. We do need to take care of this power to a power. And in doing that, we end up with 3 to the -x is equal to 3 to the 2nd. So that's how we get that. Now that the 3's match, we can set the two powers equal to each other. So we can see negative x is equal to 2, and by dividing both sides by -1, I get x equals -2. Now that one also utilized the one-to-one power where we got the bases to be the same so we can compare the powers. Now, the next four are going to use the inverse property. And so there's various ways you can go about doing this. I would say the most straightforward way for part D is to think about the very first log rule that we talked about in 5.2, which is how to convert it from a logarithmic equation into an exponential equation and vice versa, from an exponential equation into a logarithmic equation. So that very first property told us that the base of the power becomes the base of the log, and then the other two parts switch. So what we end up with is natural log, because this is log base e, of 7 equals x. So I took something that was an exponential form and I rewrote it into logarithmic form, and we have our solution. That is what x will be. You can see that's right there. Now the next one, part E, it says natural log of x is equal to -3. So this one, because it's already in logarithmic form, and we have this natural log of x, we need to get rid of this natural log. Now, some people might say, well, it's multiplying the x, so just divide by natural log on each side. That would be incorrect. Do not do that. You cannot divide by natural log. Natural log is of the x, so we need to do the opposite of natural log, which is actually an exponential. So we're going to take this from natural log form and put it into exponential. Now remember, natural log is base e, and so the base of the log becomes our base of the exponent, and then the other two parts switch. So this becomes e to the -3 power equals x. So we took it from logarithmic form into exponential form, and we've solved it. And that's where our answer comes from. X equals e to the -3. We will do the same thing for the next two. These are both in logarithmic form, and in order to solve for the x, we need to get rid of this log right here. And in order to do that, we would need to change it from logarithmic form to exponential form. Again, back to the very first rule that we learned, which is how to switch it from exponential to logarithmic form and logarithmic form to exponential form. So this, because it's not written, it is base 10. So we would write 10 to the -1st power equals x. And there's your solution. X is 10 to the -1st power. The last one is done in the same fashion. You can see we have a 3 right here. So the base of the log becomes the base of the exponent. It's 3 to the 4th power equals x. And 3 to the 4th power would be 81. If you wanted to write that, you could, or you could just leave it as 3 to the 4th. So that's how we went through and used either the one-to-one property or the inverse property to solve some basic logarithmic equations. Here are a couple strategies that were used in example 1. It says rewrite the original equation in a form that allows the use of the one-to-one property of exponential or logarithmic functions. So what they're saying is when you're given things like this, you always want to rewrite it so the bases are the same if possible, and then you can set the powers equal to each other. The next one says rewrite exponential equation in logarithmic form and apply the inverse property of logarithmic functions. And that's the first rule that we learned, how to go from exponential to logarithmic equations or from logarithmic equations to exponential. And then the last strategy is to rewrite the logarithmic equation in exponential form and apply the inverse property of exponential functions, which is pretty much the same as the second one that said. So now we're going to try maybe a little bit more complicated exponential equations. and solve them. So it says solve each equation and approximate the result to 3 decimal places if necessary. So they're saying you may have to use your graphing calculator or your regular calculator. And if you do, you want to round to 3 decimal places. So looking at this first one, you can see that I have e to the negative x squared power, and then I have e to the negative 3x minus 4. We will be able to utilize the one-to-one property because the bases of both those exponents are the same. They're both to the e power. So since it's stating that they are equal and the bases are equal, then we are going to set the exponents equal to each other. Now, once we do that, you can see that we have a quadratic equation. So we should be able to solve that by utilizing some of the properties that we have from earlier in the year. So you can see I'm going to add x squared to both sides, and I will get 0 equals x squared minus 3x minus 4. From there, I should be able to factor this into x minus 4 and x plus 1. And each of those will be set equal to 0 and solved. Whoops. And so there's our 2 solutions to that equation. X will either be 4 or x will be negative 1. Now the next one, you can see part B here, it doesn't start out the same, right? So we could see that we both had an e there, so it was easy to compare the powers, set them equal, and solve. But these ones have a little bit more work to do first. We do need to peel back this 3 right here. This 3 is on the outside. What we want to do is have 2 to a power, and we need this side to be 2 to a power. Right now, though, 42 is not a power of 2. If you go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 42 itself is not a power, so we need a way to rewrite this. What we'll do is we will divide both sides by 3 first. Now, in doing that, we end up with 14. Now, how do we solve this? Well, can we rewrite 14 as a power of 2? And the answer is no. 14 is not a power of 2. So let's go back to the directions for a second. It says solve each equation and approximate the result to 3 decimal places if necessary. So in this particular example, even though we divided both sides by 3, we still did not end up with something that is a power of 2. That's okay. We just need to utilize our properties of logs and our calculator to solve this. So what they want to know is 2 to what power will give us 14? Now, if you do a little deductive reasoning, we know that 2 squared is 4, 2 to the 3rd power is 8, 2 to the 4th power is 16. So this number is going to fall between 3 and 4, but we don't know exactly what power it is. So here's how you go about solving this. It is an exponential form. We need to solve for this x, which is up in the exponent. So the way that we do this is you convert this from exponential form to logarithmic form. And so the base of the exponent becomes the base of the log, and the other 2 parts switch. So this becomes log base 2 of 14 equals x. Now, we have a couple ways we can type that in our calculator. We can utilize the change of base formula, which is probably the way that I would suggest doing it, which is simply to do log of 14 and divide by log of 2. And when I click enter, you can see I get 3.807. So x is 3.807. So we've rounded to 3 decimal places. So what I want you to see from this is you will not always be able to utilize the one-to-one property in order to solve. You're not always going to get a power of the base. It just doesn't work like that all the time. All right, that's what I have for you today. So thanks for listening. And as always, if you guys have any questions, feel free to email me. Have a great day.